Hello, my name is Abhinath Ngusu, and I am here with my colleague Jonathan Yoon. Here we will be discussing our StockX resale price prediction project, covering from introductions all the way through from our model, as well as our results and conclusions and recommendations. Moving along, here we have our table of contents that we'll basically walk through: introductions, problem statement, data exploration, modeling, some more forecasting using time series with Yeezy brand and Off-White brand, as well as discussions/limitations, and last but not least, conclusions and next steps. Moving along, StockX is a great website based for numerous shoe brand fans to navigate their opportunities to buy and sell their sneakers. It has been noted that the resale prices are different, mostly higher than the actual retail price. The cost of such a trend is assumed to be due to several reasons, including precautions of shoes from high demand and low supply, discontinued sale, and value change over time. The sneaker market has been around for a very excessively long period of time. StockX was established in 2015, and since its debut, the online e-commerce store has taken the sneaker marketplace by storm by being one of the top contenders for reselling and collecting sneakers. Over time, StockX has been able to transition sneaker lovers of all kinds from brick and mortar stores all the way down to online stores. StockX has given the customers a new experience of shopping for their favorite pair of sneakers. For consumers that are into buying and trading stocks, StockX was able to apply the same framework for the consumers in a way that they're able to purchase their products. You're probably asking, why are we even deciding to do a research project on predicting sneaker prices? Here's the reason why. Unlike first-hand retail markets, the prices of goods are often all over the place. In second-hand markets, where pre-owned or used products are sold, the prices are very dependent on the demands of the products. The value of products is thus a reflection of how precious the products are, especially in the second-hand market. It is truly necessary to identify the price that reflects the value accurately. Properly determining the right reselling price of sneakers so that both the sellers and the buyers are satisfied with the business is very important. Also, this would also help StockX figure out what price range it should suggest to the selling customers. The purpose of this research and the model construction is to determine the adequate shoe price of certain models of sneakers so that both the resellers and the buyers know what price level they should be looking at for their desired transactions. Here we'll be discussing data exploration analysis. First, we can see a count plot of shoe brands. This pretty much is a visualization of how much of these two shoes are Yeezy and Off-White are in the data. There are more Yeezy sneakers that are in our data set than there are Off-White shoes. And you can tell that by our visualization. And when we say Yeezys, we're talking about different types of Yeezy sneakers, from Yeezy version 1, version 2. There are different variations of them, as well as Off-Whites. In addition to that, we can look at, in the right, we can see average sale price by brand. We can see, as far as sales price goes, there are more consumers purchasing Off-Whites more than they are purchasing Yeezys. This pretty much says a lot. Off-Whites are a better investment in terms of long-term investment, in terms of maybe you might buy it for $200 today, and then in 6 months that same 200 pair of sneakers of Off-Whites might be $500 or $1,000. So that could definitely be a thing that's going on. But also, Yeezy has not been doing the best in the news either, especially with Kanye West. His company has taken a big impact and a big hit, so maybe that might be why no one's really purchasing sneakers. But we'll see further along in our research. We'll also be looking at statistical summary of our sale price, retail price, and shoe size. Here we can see a summary statistics, which provides us with valuable insights into the distribution of our variables. For example, we can see that the mean sale price of sneakers on StockX is $413.77, while the mean retail price is $209.21. We can see also that the average shoe size is 9.35, with a standard deviation of 2.34. By examining the summary statistics, we can better understand the characteristics of the market for sneakers in StockX. This can help us identify trends and patterns, which can be useful for predicting future prices and making strategic decisions. For example, we can see that the minimum sale price is $186, while the maximum is $950. This tells us that there's a wide range of difference for sneakers in StockX, and that some sneakers are sought after that can command premium prices, as well as change over time. Additionally, the fact that additionally, the fact that the mean sale price is higher than the mean retail price tells us something very important. It tells us that there's a significant markup on sneakers sold on StockX. This may be due to such factors such as scarcity and high demand for certain sneakers, which also can drive up prices. Overall, Summary Statistics provides us with a valuable starting point for analyzing the data and developing insights that can help us achieve our goal of predicting future prices on StockX. Moving along, we can move along to the heat map and correlation. For heat map and correlations, we also use our numeric variables. We can see that there's negative correlation between sales price and retail price, which pretty much indicates that the retail price of a shoe goes up and the sale price tends to go down. This makes sense because of a shoe that is priced too high compared to its retail price will likely not sell at the higher price point. The positive correlation of 0.083 between shoe size and sales price indicates that there's a small positive relationship between the two variables, suggests that as the shoe size increases, the sale price may increase slightly. However, the correlation is not strong enough to make a collective statement. And due to that, we'll move on to negative correlation of negative 0.047 between retail price and shoe size, which also indicates that there's a weak negative relationship between these two variables. We know that. However, this is a suggestion that as the shoe size increases, the retail price may slightly decrease. But again, the correlation is not strong enough to make a conclusive statement. Overall, these correlations give us a starting point for understanding the relationships between the variables and may help us in creating a model to predict future price. However, it is important to note that the correlations do not always imply causations, and further analysis and modeling is necessary to make accurate predictions. In addition to that, we can look at our line plot of sale price per release date. We can see that this gives us a trend of sales price over time. The graph shows us that the sales price was high in the year 2015 and took a big dip before starting to rise again in 2018. However, the trend after 2018 seems to be an up and down situation. This can indicate that at first it could mean that some of the brands released highly sought after shoes in 2015 that were in high demand and therefore commanded a high price. Then perhaps the market became saturated with these shoes, leading to a dip in sales price. The subsequent rises in price in 2018 could have been due to the release of new highly sought after shoes. The up and down trend after 2018 can indicate fluctuations in demand for brand shoes or changes in the market overall. A line plot of release date can help us understand the trend in sales price over time, and definitely can help us identify any patterns or change in the market. Moving along, we'll be looking at cleaning and feature engineering. Here we have a couple box plots of sales price and retail price, as well as shoe size. Here, before removing the outliers for sales price, there's a big deal of outliers in there that need to be removed, some data points. So we decided to remove those, which gave us a full data set row of 93,290. And after removing it, you can see right here that there are not that much data points or outliers left, which is good for us. This is as good as we get the sales price to be. However, for box plot for retail price and shoe size, we saw that there weren't really that many outliers, and we did not see a reason or a need to remove anymore. Keep it exactly as it is. So we only focused on sales price outlier removal. In addition to that, we performed some feature engineering to help us with our modeling. The dollar sign sales price and retail price were removed so that only numerical values are there for these features. This helps us out not only in our modeling, but also summary statistics. In addition to that, something big that really helped us out was removing duplicate rows with the same values across all columns. That was a big help, and we did that as well. And there's some other feature engineering that we did, for example, with our non-numeric variables such as sneaker names and countries where these products were bought. We changed those to numerical variables. And next we'll be moving on to modeling, where my colleague Jonathan Yoon will be taking over. Thank you so much for listening, and Jonathan, please take it over. Thank you.
Thank you, Ebenezer. Hi, my name is Jonathan Yoon, and I am going to introduce the modeling we tried and the results from each model. First, non-time series models based on shoe feature analysis were constructed. After engineering features to optimize for modeling, the dataset was split into 80% training data and 20% test data. Then, the training data was applied for random forest model without any tuning. After that, the feature parameters were tuned into optimal, and the tuned parameters were applied into random forest model. Another method we used was gradient boosting method. Like we did in the random forest method, a model was constructed without tuning the parameters, and then another gradient boosting model was constructed after tuning the parameters. Therefore, there were a total of 4 models in the feature-based predictive models. For evaluation, mean absolute error, mean square error, root mean square error, and R-squared scores against the test set were calculated. For time series analysis, we constructed different models for each brand, Easy and Off-White. For each brand, we split the resale price time series into 2 parts. Training series with resale prices from September 2017 to December 2018, and then testing series with resale prices from January 2019 to February 2019. 3 models were constructed on each brand based on training series, and those models were naive prediction, seasonal autoregressive integrated with moving average or SARIMA, and exponential smoothing. Each model was compared against the test series, and mean error, root mean square error, mean absolute error, mean percentage error, and mean absolute percentage error were measured for evaluation. Now with the feature-based non-time series predictive models, random forest model without parameter tuning shows the best performance based on the evaluation metrics. Among the 4 models, this model has the lowest mean absolute error, mean square error, and root mean squared error scores, and it has the highest R-squared score. As you can see from this figure, for each algorithm, random forest model shows better performance before parameter tuning, but gradient boosting shows better performance after parameter tuning. Overall, random forest model shows the least mean absolute error, mean square error, and root mean square error values, and this supports our conclusion that the random forest model without parameter tuning performs the best among the 4 models created. For time series, we will present separately for each brand. First, with Easy brand, the 3 models, naive, SARIMA, and exponential smoothing, all show very high error scores with greater than 70% errors. Naive and exponential smoothing models even show greater than 100% error scores. Therefore, time series on price prediction of Easy brand is not recommended using these 3 models. To better visualize the time series forecasting models, a figure is generated. And as you can see, price fluctuations from $200 to almost $1,000 are seen in both training and test sets. This explains that the resale price forecasting based on the historical price trend on Easy brand cannot be performed accurately. For the Off-White brand, naive and SARIMA models show relatively good performance with much lower error scores compared to the Easy brand. Especially, SARIMA model has a 5.5% mean percent error on forecasting, which indicates good performance. Overall, it may be recommended to use time series analysis to forecast resale prices on Off-White brand. This figure shows the trend graph of the resale price of Off-White brand. As you can see, there are also fluctuations in resale prices, and we may say that, like an Easy brand, forecasting of resale price simply based on price trend time series might not be a great idea for resale price prediction. As a result, the best model among the 4 candidates we created based on feature analysis is the random forest model without parameter tuning, since it has the lowest error scores and the highest R-squared value. However, resale price prediction simply based on the price trend time series is not recommended, since it shows high error scores and big fluctuations. Some limitations can be considered. One is that the dataset was too limited to the StockX website. We may want to integrate datasets from other platforms so deeper and more accurate analysis on resale prices can be performed, and thus the predicted resale price may reflect the accurate resale price in the market. Also, limited features in the dataset and limited dating can also be a limitation. If we introduce more features such as popularity, it can definitely improve the predictability of our models. Also, in time series, if the time frame of the price trend was longer, the predictability of the forecasting models would have been much better. We can also have tried other algorithms and or other hyperparameter tuning setups to see if any of those may have better accuracies in predictions. In conclusion, we can now introduce our random forest model without parameter tuning to the StockX app. Then StockX can allow customers to estimate the future resale price of the sneakers of their choice. In addition, the company can benefit from this price estimate model by leveraging sales data to optimize on inventory management. For our next steps, we can keep track of the sales data and apply it to the model to improve its accuracy. Also, different algorithms and hyperparameter tuning methods can be applied as we gather more data to improve the performance of our predictive model. With greater amount of data, we can get aid from Amazon Web Services or AWS or Google Cloud for better model constructions as well. Thank you very much for watching our presentation. It has been a great pleasure. Thank you.